class. So today's notes are going to be all about factoring. So we're going to talk about different types of ways that we can factor. And factoring is really the process of undoing multiplication. So how can we talk about undoing all of the stuff that we've been looking at the last couple weeks? So the first type of factoring that we're going to look at is prime factoring. And prime factoring is actually something you've been doing for a long time. Most of my students think about it as that tree thing, where they sort of know it when they see it, they just don't know the term. So the first thing we need to understand is that a prime number is a number that has nothing that will divide into it evenly other than 1 in itself. So 3 is a prime factor because 1 times 3 is the only thing that gives us 3. Whereas 9 is not a prime factor because 9 is 1 times 9 and 3 times 3. So when we're talking about prime factoring, we're going to be talking about taking a number and breaking it up until we get to primes. Okay, so we're going to take a number, right, and we're going to do this little tree thing off of it and say, okay, what divides evenly into 20? And even if you say, I don't know, pick up a calculator and try something. So like this is even, so we can divide it by 2. So in your calculator, you could do 20 divided by 2, which gives you 10. Now 2, we can't split up any further because 2 is just 1 times 2. There's nothing else. So because we can't split it up any further, we're done with the 2. Okay, but we can split up the 10 further. The 10 will split into 2 times 5. Okay, now if we try and split up 2, 2 can't go any further. And if we try and split up 5, 5 can't go any further either, right? It's just 1 times 5. So all of these numbers that we get at the end that we can't split up any further make up our prime factorization. So we would say that 20 prime factors into 2 times 2 times 5. Now, we can do this same process if there are letters involved. So maybe we want to prime factor something like 42x squared y to the third. So if we want to prime factor a monomial, right, we have these variables. Mono as a prefix means 1, so there's just one thing here. We're going to start by just looking at the coefficient, that big number in front. We're going to say, okay, what can we split 42 into? And again, if you don't know, pick up your calculator, try and divide it. You can see that it's even and just go with 2. And so 42 divided by 2 gives us 21. Now 2, I can't split up any further, so I'm done with that one. Okay, then 21. Now you might think 21 is odd, so maybe it can't, but right, 21 is 3 times 7. So I can't split up the 3 any further because that's just 1 times 3. And if we think about 7, right, 7 is just 1 times 7. So far we have a 2 times a 3 times a 7. Now, typically you're going to see these numbers down here written in numerical order. Sorry, these numbers here will be written in numerical order. Okay, they don't necessarily have to be for what we're doing, but you'll like them to be in numerical order in the long run. But we're not done yet because we still have to consider these letters up here. So now we need to think about x squared and how we're going to prime factor x squared. Well, remember, we said that exponent just tells us how many times to multiply the base. So whatever number we have as the exponent is the number of times that we're going to write x. So I'm just going to add on here 1, 2 x's. Okay, and then I'm going to do the same thing for the y. So this has an exponent of 3. So I'm going to add on 1, 2, 3 y's. And there's always multiplication in between them all. So this is a 2 times 3 times 7 times x times y times y times y. So kind of long, but not necessarily difficult to get that answer there. Now, the second type of factoring that we're going to talk about today involves a GCF. So the first thing that we have to remember is, okay, what is a GCF? The GCF stands for the greatest common factor, right? There's that factor piece there where we want to find the largest number that will go into a certain number of terms. Now, sometimes this will jump out at us. If we have numbers like 4 and 12, that's a terrible 4, but my students typically can look at this and go, well, duh, 4 will go into both 4 and 12, and that's the largest number, and so my GCF is 12. The problem is that the numbers aren't always that small. They won't necessarily jump out at us. And for some of us, seeing those numbers as a GCF are easier than others. So I want to show you a way that you can find a GCF no matter what the problem is. So let's say we want to find the GCF of 45x to the third, 120x squared, and let's see, how about we do 135x? Now, for most of us, we're not just going to look at these problems and say, oh, a GCF automatically jumps out at us. But what we might notice is that they all end in a 5 or a 0, which means that they all have a factor of 5 within it. Okay, so I'm just looking at the numbers and I'm saying, okay, I can divide those all by 5. So again, I'm just focusing on the numbers right now. So we're going to take those variables and just ignore them. Just setting those over there to the side, I'm ignoring them. Okay, so I see that 5 will go into all of them. So now I'm going to divide them all by 5. So 45 divided by 5 is 9. And again, feel free to use a calculator. I have to sometimes when the numbers get really big. It just helps my brain think about the other stuff that I want to focus on. Okay, and so when I divide 45 by 5, I get 9. 120 divided by 5 is 24, and 135 divided by 5 is 27. Okay, so now I'm going to ask myself again, what can I think of that will go into 9, 24, and 27? And again, if you struggle with this, you might just have to pick up your calculator and try, right? What are some numbers that we know go into 9? So if I just look at 9, okay, I know that 9 is divisible by 3. So now let's check in our calculator if the other numbers are divisible by 3, and they are. So 9 divided by 3 is 3, 24 divided by 3 is 8, and 27 divided by 3 is 9. Okay, now I know I can't go any further. 3 is already prime, so unless 3 would go into all of them, which it doesn't, right? 3 doesn't go into 8. So I know I can't go any further. What I'm going to do then is I'm going to take all the different numbers that I divided by, and I'm going to multiply them together. Okay, so 5 times 3 is 15. Okay, so my GCF so far is 15. And now I need to consider the letters. So now I'm going to go back and look at that yellow highlighted stuff. Okay, and whenever letters are involved, if they all have the variable, okay, so every single one has an x, I want to take the smallest exponent. Okay, so I want the smallest out of 3, 2, and right when there's nothing there, there's a 1. So my smallest exponent would be x to the first. So that is going to be part of my GCF. So my GCF for this is 15x to the first. Now, not every problem will be this long. Oftentimes, we're not dealing with something that big, but in fact, what we're dealing with is the polynomial to start with, right? It's the factoring part that we really want to consider. Okay, and so instead of just having random numbers, okay, we're going to have a polynomial. So maybe we'll have 20x to the third plus 15x squared minus 25x. Okay, and our goal will be to factor out the GCF. So if we want to factor out the GCF, I need to first find the GCF. So again, if I look at 20, 15, and 25, we want to think of a number that will go into all of them. Okay, and they are all divisible by 5. So 20 divided by 5 is 4. 15 divided by 5 is 3. 25 divided by 5 is 5. Okay, so I'm left with a 4, a 3, and a 5. There's nothing else that will go into all 3 of them. Okay, but I don't have the full GCF yet because I still need to consider if they all have the letter. Okay, and they do all have the variable of x. The smallest one is x to the first power. Okay, so my GCF is going to be 5x. But for me to factor, right, just like when we were prime factoring way back over here, right, when we were prime factoring, we were doing a multiplication. This was all stuff being multiplied. So factoring means we need some multiplication. So we're going to take this 5x and we are going to put in parentheses for multiplication. And we're going to finish filling in all this stuff in the middle. So we said 20 divided by 5 was 4, but now let's take a look at those exponents. So now let's take a look at x to the third divided by x, right? And when we divide, we subtract exponents. Okay, so we're taking, look at this, a 3 minus a 1, which gives us a 2. So positive here. A 2 minus a 1 gives us a 1. We have a subtraction here. And a 1 minus a 1 gives us nothing, so there's no x on the end. And this is our factored answer. Okay, so we're going to look at one more. How about we have 48 to the 5th plus 80 x to the 3rd. And we're going to factor out the GCF. So again, the first thing we're going to do is we're going to look at 48 and 80. We're looking at the numbers and we're say, okay, what can we think of that will divide into both of those? And probably the first thing that my students would see is 8. It could be a 2, it could be a 4, it could be whatever. As long as it's correct, it doesn't matter what you pick. Okay, so if we do 48 divided by 8, we get a 6. And if we do an 80 divided by 8, we get a 10. Okay, so now at this point, if we look at 6 and 10, what goes into 6 that will also go into 10, we can divide out again and we can pull out a 2. So that will give us a 3 and a 5. Okay, we can't go any further, so that means we have enough info right here between these two, right? We said with these two numbers, we would multiply them, right? We are multiplying those. So 8 times 2 gives us a 16. But we're not done finding our GCF because we can't forget our letters. So we said to find that, we would use the smallest exponent. They both have an x. The smaller exponent is 3. Okay, so since my smallest exponent is 3, I now have 16x to the 3rd. I'm multiplying that because that's what factoring tells me to do. And now I need to consider my exponents. So 5 minus 3 gives me 2. 3 minus 3 gives me 0, so no x on the end, and that was an addition sign there. And there is our final answer.